Once again, I welcome all the viewers, especially the class 10 student, to this online class. To recall, in the previous class, I have done about the chemical properties of acids and bases. So today, I am going to do about the pH scale, meaning of salt and the different types of salt. To start with the topic, first I want you to understand what is universal indicator. In the previous class, we have seen there are different types of indicators, right? But this universal indicator is very effective because it does not determine only the nature of the substances, but it also determines the strength of the acid and the bases. So, universal indicator is a mixture of several indicators. Universal indicator is the mixture of several indicators. Alright, and this universal indicator has a scale which measures the concentration of hydrogen ion, and that scale is known as pH scale. pH scale. Right. So this pH scale has two terms, that is from pH we have P and H. P has the meaning of potence. P means potence or power, which is taken from the German language, and H is the hydrogen. This pH scale measures the concentration of hydrogen ion. That is, it measures the concentration of hydrogen ion. Alright, so here I have the pH scale. This is the structure of pH scale. In this pH scale, it has a reading from 0 to 14. Alright, it varies from 0 to 14, and this pH scale decides that whether the solution is acidic or basic. If the pH has a value 0, it means the solution is very acidic. And if the pH has a value 14, it means that the solution is very basic, and that, or we can say very alkaline. So, in this pH, alright, if the value, in this pH, the value from 0 to 7, it indicates a acidic nature. 7 indicates a neutral value. From 7 to 14, it indicates the basic nature. So it means as we go down from 7 to 0, the value of pH is decreasing and the concentration of H plus ion is increasing. Alright, so here, for example, we have, this is the pH scale, 0, here we have somewhere 7, and this is 14. As you go down from 7 to 0, the value of hydrogen ion is increasing and the pH value is decreasing. And as you go from 7 to 14, the concentration of hydrogen ion is decreasing and the value of pH is increasing. Alright, and or we can see also from 7 to 14, it indicates the concentration of hydroxide ion. So this is all about the pH scale. And now we will see what are salts and the different types of salt. So, to recall, we already know that salt can be formed by the reaction of acid and a base, right? Here, the salt is formed by the reaction of acid and a base. You will get salt and water. So this reaction is known as neutralization reaction. For an example, let me take the common salt, sodium chloride. Here, sodium chloride, NaCl. This is the common salt that we used to have every day. And from this common salt NaCl, we will have the positive ion, which is the base, and the negative ion, which is the acid. So clearly we can define what is a salt. And a salt is any ionic compound which contain the positive ion other than hydrogen ion and the negative ion other than the hydroxide or oxide ion. Salts are those ionic compound containing positive ion other than hydrogen ion and negative ion other than hydroxide ion or oxide ion. Right? You might be thinking we have only one type of salt, that is the common salt, but that is not the case. We'll have different types of salt based on the strength of the acid and the bases. If you have a strong acid and a strong base, you will get a salt, let's say, of pH 7, right? If you have a strong acid and a strong base, you will get a salt, let's say, of pH 7. So this salt is neutral, right? Or we call it as the normal salt. Neutral salt. Right? But if you react between a strong acid and a weak base, what you will get? Strong acid and weak base. What type of salt we will get? Obviously, we will get an acidic salt, right? Acidic salt. And this salt has pH less than 7, right? Next, if you react a weak acid and a strong base, what type of salt you will get? Weak acid and a strong base. So in this case, you are going to get the basic salt. Basic salt. And this salt has pH more than 7. So these are the 3 different types of salt. The normal salt, acidic salt and the basic salt. Now, having understood the meaning of salt, let us see the different types of salt. The first salt is bleaching powder. First salt is bleaching powder. The scientific name of bleaching powder is calcium oxychloride, right? The scientific name of bleaching powder is calcium oxychloride, and the chemical formula is CaOCl2, right? So how does this bleaching powder is produced? We know bleaching powder contains chlorine, right? So bleaching powder is produced by passing the chlorine gas into the slaked lime. So what is the chemical formula of slaked lime? It is CaOH or calcium hydroxide. So when you react the calcium hydroxide or the slaked lime with chlorine gas, right? You will get CaOCl2 and H2. So this is the calcium oxychloride or the bleaching powder. Alright. So bleaching powder has many uses. Some of the uses of bleaching powder are: it can be used in the textile industry, it can be used for laundering purposes, or it can be used for disinfecting the drinking water. I believe you have understood the meaning of bleaching powder and its uses. Now let us see the second salt, that is baking soda. Baking soda. Right. The second salt is baking soda. The scientific name of baking soda is sodium hydrogen carbonate. That is sodium hydrogen carbonate. And the chemical formula is NaHCO3. Right. How does baking soda is produced? It is produced by the reaction of sodium chloride, water, carbon dioxide and ammonia. To understand that, here I'll write the reaction: sodium chloride, water, carbon dioxide and ammonia. So we are going to get sodium hydrogen carbonate. From here you have NaHCO3. Alright. Then the remaining is ammonium chloride, NH4Cl. So this is the baking soda or the sodium hydrogen carbonate. And baking soda also has many uses. You might be thinking it can be used only for cooking purposes, but that is not the case. It can also be used for manufacturing baking powder. It can be used as an antacid, or it can be used as a fire extinguisher. The third salt we are going to do is washing soda. Third salt is washing soda. Right. So we will do the third salt, that is washing soda. The scientific name of washing soda is sodium carbonate decahydrate. It is sodium carbonate decahydrate. And the chemical formula is Na2CO3 then H2O. Right? Okay. So how does this washing soda is produced? First, we need the baking soda. On heating baking soda, we will get sodium carbonate. Alright, let's see. On heating baking soda, we know baking soda is sodium hydrogen carbonate. This is in solid. So when we undergo heating this, you will get sodium carbonate Na2CO3. So we need to balance, multiply it by 2 and water. Right? So you will get sodium carbonate. Now, using this sodium carbonate, dissolving sodium carbonate in excess amount of water, you are going to get sodium carbonate decahydrate. So undergo that by dissolving in water, Na2CO3 and then H2O. So we will get from here Na2CO3 dot then H2O. So this is the required washing soda. Alright. So you might be thinking that washing soda also it can be used only for the cleaning purposes, but that is not the case. It can also be used in the glass, paper and soap industries. It can be used in the glass, soap and paper industry. It can be used for softening hard water also, or it can be used for cleaning the domestic purposes. Alright. So here you might be thinking, what does this 10H2O signify? Alright. This 10H2O is the water molecule or water crystallization. What is water of crystallization? It is the fixed number of water molecule in every molecule of a salt. Like in this case, this is the fixed number of water molecule in every molecule of sodium carbonate. Right. There is another salt also which has water of crystallization, which is generally known as gypsum. Gypsum is also one of the example which has water of crystallization. It has two molecules of water as the water of crystallization, and the chemical formula is like this. Gypsum has a chemical formula of CaSO4.2H2O. This is the chemical formula of gypsum. Very interesting from here, when we undergo heating gypsum, it will lose some amount of water molecule and we will get another salt, and that is plaster of Paris. When we undergo heating this CaSO4.2H2O at 373 Kelvin, we will get CaSO4.12H2O and 3/2H2O. Right, it will lose some amount of water. You get another salt, calcium sulfate hemihydrate, or we call it as plaster of Paris. Alright, so here what do we observe? If we undergo heating gypsum, it loses some amount of water, we'll get plaster of Paris. Or if you add water in the plaster of Paris, you will get back gypsum. This is a two-way process, right? Plaster of Paris can be used, most of the time it can be used by the doctors in order for keeping their fractured bone in the right position, or it can be used for making toys and other decorative materials. So this is the end of the chapter. I believe you have understood about everything that we have done in this chapter. So study hard, stay safe, take care.